but I'll start. Okay. Thank you for the recording. One of the things I'll just start with is the housekeeping. So if you want to stay on mute, if you have a question, raise your hand. We have our notes where we can sort of record questions and our notes, of course, and where we have other sort of links to material. We have a code of conduct, and I'll sort of cover that shortly. But hopefully in the chat, the links to our notes are being shared, so I don't have to. But I'll just pause there if you wanted to copy that for a second. Please mute if I heard someone that was maybe not on mute. Okay, I think they were muted. So our code of conduct. So really, it's to be respectful. This is a welcoming space. So try to treat everyone just with respect and be patient. We have a link to our guidelines, participation guidelines, that's in the slides, hopefully shared as well. But also just reach out to us maybe on the side. So Donnie Winston, who will introduce himself later as well, and myself, if there's anything you want to tell us about regarding the code of conduct. So just to back up again, what is this series of this Ask Me Anything style event series is really born out of a grant, a project, an ambassadorship with RDA, Research Data Alliance, and EOSC, where we sort of explore some of these topics around FAIR. So the first one we had was around identifiers. Second one was around software and workflows. This one today is about machine actionability. We have some upcoming ones. So Hugging Face, for those of you who don't know what Hugging Face is, it's a modeled computational model discovery platform. So in machine learning, you may have come across links from it, but we'll be having the machine learning librarian talk to us about how you can make these models more discoverable. The other series that parts of the series that we have is the equitable and transparent access to information and knowledge, and that will be later in September, October, I believe. And the other one that we have is we're planning for International Data Week, so regulatory process and governance. So those are the events in this series. I wanted to just give you a brief overview of FAIRPoints. So FAIRPoints really involves all these organizations on the side that you see. So SciLife Go Fair US and some others, San Diego Supercomputing Center. We already mentioned some of the others, but also FAIR Digital Objects. And then our team as well. You can see our faces, so I'm there, but the others can introduce themselves as well. But Sarah is not here, and potentially Nabil is out there right now, but Sarah unfortunately couldn't make it for this call today. And I wanted to just briefly describe what do we do at FAIRPoints. We have community discussions, keynote events like this one, the AMA series. And we're also sort of regrouping to look at what we're going to do for next year. We have some events, but we're looking at maybe what we might do there. And then podcasts. So there's the opportunity of podcasts. And one of them is run by Donnie Winston, who you'll hear about later, where we actually have a podcast that we point to on machine actionability from his series. And then Research Space also runs a FAIR Data podcast who we work with, and we forgot their logo on the side there, but they've been running a FAIR Data podcast series as well. And we have some projects that we have sort of, like that we're working on or that will be coming up soon. But I think really to wrap this all up is it would be great to work with you if you're interested in FAIR and want to work with us and do some things along this, do some events or host some discussions. Do a podcast or think about projects with us. It would be great if you would like to get involved and join us. So we're at a certain point of time where we're thinking about sort of the next year and maybe the year after. So it'd be great if we had some other team members join us. And then just some other links for you to know about. So the fairpoints.org website, and then the sign up to the event series. So all those events that you saw earlier, you can sign up to the events as well, so you can catch them. And then we have Twitter and Mastodon links, and the Slack, I think highly recommend joining. It is sometimes quiet, but sometimes it's a great resource. It gets active, and there is some discussion on there. And so we're still growing. So again, if you want to get involved, let us know. I'll just get us started on this topic. I think I'll just pause actually for a second, because I know that also Donnie was going to just introduce the topic briefly. So before I go into my part of the slide, so Donnie, if you wanted to just briefly discover talk about what we'll be talking about today. I don't think I had the sort of background on that, but yeah, if you can unmute and introduce yourself.
Sure. Hello, everyone. I'm Donnie Winston, an independent research data engineer. I'm with FAIRPoints as well. Today, as part of an RDA EOSC grant that we got through Sarah, we're doing a bunch of stuff on the theme of RDA's 10th anniversary. Today is machine actionability. So we've got an expert, Claus, here, and others as well as moderators, and also people who are just here, and we're going to talk about metadata for machine actionability and how we realize that. And this is all about your questions and whatever you're bringing to the table, and we're here to facilitate that. In terms of FAIRPoints, what we try to do is try to hopefully verify these events themselves actually, and their discussion outcomes, and make them machine actionable, so we can learn from each other on a continuing basis. And I'll talk a little bit more about that for a few minutes before Klaus's talk. So that's just a little bit about what we're doing today. We're going to learn about machine actionability and just learn it together. Okay, back to you, Chris.
All right. So thanks. Yeah, thanks, Donnie. So just full confession time. Sarah couldn't be here today, so I'll be doing my best to represent some of her slides. And we also had another speaker that couldn't make it. So we're trying to sort of fill in for some illnesses and other unfortunate events. And bear with us. But I will try to represent Sarah's slides as best as I can. And I'll start with, so Sarah wanted to start us off with just a little bit of background on sort of metadata and why it's important for this particular conversation. So I like to think that she was starting off with like the trend in memes that you think about, how it started versus how it's going. If anyone knows your meme. I didn't want to include an image for that, so you search Google for the meme you want to use here for this topic. But I just wanted to cover the fact that she starts with the semantic web. She starts with the web, and we know how that story goes. We linked to all these things. We had sort of a structure, a minimal structure to start off with the web and hypertext infrastructure. But now, we're sort of at the point where we've linked all these things, but we have this sort of, disconnected and scattered landscape that we're trying to make sense of, and apply sort of approaches and technologies, and also try to improve how we structure metadata. In that sense, and let me try to move the bar here. I can't. So where we're at the moment is really trying to sort of structure this information. And so Sarah calls up sort of these different topics to cover here. So the objects, which we're talking about, structure, the connections, the meaning behind them, of sort of the work behind that. And she goes into a little bit more background about, what is an object. So, that can mean data sets. And there's particular work on the FAIR data objects side of things to make those a little bit more actionable. And we'll hear more about that later. And then the semantic standards that we have for sort of understanding things being sort of processed from the machine side of things, and the models sort of helping with structuring that, particularly from the domain side. And then she calls out sort of the identifier side, so persistent identifiers. DOIs are one of sort of the common ones that are sometimes referred to, but URIs in general. So these links, these uniform resource identifiers that link everything. And then, the sort of data about data, right? Metadata is that, and this sort of ontologies aspect of like how we can sort of provide some more of that structure, the hierarchy and linking concepts together. And this is a particular, really challenging area, to tell you the truth. In fact, that's actually one area that we're pursuing at Michael J. Fox Foundation, is to try and create a sort of ontology for Parkinson's research. But it's a place where sometimes resources are strapped. But it's a place where we need a lot of work. So this is a slide that I actually particularly like from Sarah, is that she pulls up this pulls everything together and brings up this analogy of water flowing through the pipes, and that's the data. The semantic web in this sense could be the interconnected pipes, so you can see them sort of interconnected in that visual. The ontologies are sort of the classification chart, how things are sort of typed, and just other sort of measures that you can think about. The URIs in this sense are there's sort of unique identifiers for each of these pipes in the network, and the metadata are the sort of tags for labeling those pipes, and describing what's in the water inside. So I thought that was a really good analogy from Sarah, just to sort of briefly give you an overview, describe this particular aspect. I wanted to sort of delve a little bit more deeply into sort of the challenges with this. One of the things that at least particularly in my work, and I'll say from my side, thinking about open science from the funder perspective, is that we're trying to extract value from all this work that researchers are doing. So I chose this common slide that you see about metadata being a love note to the future, is that I am encountering this through my work, is that that in many ways there could have been more advantageous things happening if the metadata had been done a little bit more properly, if we've been a little bit more vigorous. And so I'll tell a little bit more about what I mean by that, the challenges. And I have this sort of example of documenting the work that I did at recently with Michael J. Fox Foundation, using OpenRefine, looking at all these sort of links between objects, and trying to sort of get a better understanding of how we're doing as an organization, but even getting to the step of how do we leverage the data that's being shared? How do we leverage the software that's being shared by our researchers? And the challenge is, the one thing that I wanted to bring up in this case is and what Sarah brought up, are URIs, the persistent identifiers, and the links. At least that's sort of a minimal, approach. We're finding that that's even challenging, right? To try and associate all those links and extract some value like that. And I'll bring up one example, particularly with this, especially with data and software, is that in many ways the the common form of communication is journal publications, right? Articles. And so we look at those articles, we try to extract some value out of them. The authors sort of have a way to sort of structure that information. So they share data, links, or software. There may not be even any links. There may be data available upon request, or there may be mentions of things. And I think that that's one of the sort of challenging places is we have people maybe sharing links. Hopefully, they're sharing these persistent identifiers. But then a lot of that information doesn't get communicated on. So really the way to leverage these resources is through DOIs and to be cited, by through the journals and through these publications, to be indexed through systems like Crossref and DataCite. But that's not even something we can rely on at the moment. So we're kind of still at this point of trying to mine papers and extract the information that we can in sections like availability section, which are not always present. And so reality is we're still trapped in this challenge of how do we extract all the data sets that have been associated with these papers, and how do we leverage that? And so that's something that can be at a minimum could be helped through like something like identifiers and through repositories. And so that's what we're grappling with at the moment. So what we're sort of what kind of scenario that we're in and we're kind of forced to do is mine publications. The other thing I should sort of point to here is that it's very important that these publications are open, because access, allows us to peer more into the papers and extract some of these some of this information. So just to give you an example, this is one of the things that Aligning Science across Parkinson's does. They leverage DataSeer. And in another case, PLOS does this with their open science indicators. So they leverage DataSeer to mine these publications for these mentions and links, and we try to do our best to link to these resources. On the other hand, it's also very difficult to contribute back this information to systems, to the research graph, so others can benefit from it. So that's another thing that we're sort of wrangling through right now is trying to create these relationships, event data back to DataCite and Crossref. So that there's that side of it. Yeah, these are just some examples. So Paywall is a service that, thankfully, this is one thing that works well, is that we can actually associate DOIs, paper DOIs, with Paywall and understand open access. But there's another example, like Google Scholar indexes papers, more papers than on Paywall for open access purposes. And yet, it's very difficult to sort of match DOIs with Google Scholar, what they index. So that's an example of where we're still wrangling with things too. But Paywall is a great example. And then, there's services like GrowBid where you can it's actually a package where you can go and extract value from papers, so that's another thing sort of you can leverage. And DataCite is trying to build a corpus of all these links at the moment, but that will be a pretty big project. And so, we have these challenges. And so I wanted to set the stage for Donnie, who would go into a little bit more into this as well. And but I actually forgot there was one more slide I wanted to mention, is that at least at the moment, from the ASAP, from the Aligning Science across Parkinson's perspective, we have a catalog where we put all these outputs that we ask. We require these things from researchers that we fund. And so we have an outputs catalog, but we can do more. We know we can do more to link all these outputs together. And so that's why something like the research activity identifier, RAID, the project identifier, is going to be really helpful for this, of really of really just aggregating all these outputs into sort of a more meaningful representation. So that's one thing we're sort of working on too, but that's another example of using these links, these URIs, these persistent identifiers to help with sort of making sense of data. And so Donnie, I'll pass it on to you.
Great, thanks, Chris. Hopefully, people have seen the links to the Google Doc in the notes. We've been keeping posting it. I'll post it again here. This is where we'll have roll call, we'll have Q&A throughout the entire session, that sort of thing. So before we get on to our invited speaker here in the Q&A, I want to just briefly talk about some of the things we've been doing at FAIRPoints itself and thinking about metadata in action. So I'm just going to go over a few thoughts that I had here. So number one, a lot of us are used to the language of the web, document web, HTML. And there are a few indicators that tell you what machines can do, like little anchor tags for links. This is how Google crawled the entire web of links and used its PageRank algorithm, because at least we know that a page links to another page. We might not know what that link means, but we know that there are those links, so we have some sense of endorsement, and we can throw lots of computers at it. Little things like forms that allow using the HTTP protocol to submit contact forms and that sort of thing. And if you annotate inputs with say type email, your browser can know oh, this definitely isn't a valid email. If it's a type password field, it knows to show little dots so someone's not looking over your shoulder. Just little hints like that through the metadata of documents help with machine actionability. Some other things you might not be as aware of are in the header of HTML. There are these things called meta tags and link tags. These sort of help you load other things like styles. If you've ever seen a blog and subscribed to an RSS feed or a podcast, any podcast page that has a podcast link has a link tag in the header that's of type RSS XML that has a link to the feed. So this is how your podcast readers, so how say you can enter in a form in your Apple Podcast or Google Podcast, can know how to tell what the next episode is, what its title is, how long it is, what the link to the MP3 is. Just little things like machine actionability. We've been starting to get a bit better in terms of data sets. So scheme.org is one thing where you put in a little JSON in a page header. And one thing we've been doing with FAIRPoints is to look at scheme.org learning resources and Q&A pages. This is used in say Google structured search. You might have a question and get an actual question answer at the top of the page apart from your little list of links. So this scheme.org is a language that helps search engines to know a little bit about stuff. It's also what's used in Google dataset search. When you have on your web page up you have a script tag that says, hey, this is a data set. This is a scheme.org data set. Google knows to crawl that. So we're trying to do things like that, but with these events essentially. So we have some prototyping of that on our GitHub, github.com/fairpoints. You can go ahead and check that out. But just apart from that, a lot of what this is about is maybe going beyond just simple document annotation and how to actually make things more actionable across sets, exactly as Chris mentioned. Okay, just wanted to briefly do that and then get out of the way. I'm going to introduce, so what's happening now is we have our invited speaker Claus, and we have a bunch of moderators for Q&A on whatever you've heard from Claus or from our intros or anything in general for most of the rest of the session. So I'm just going to introduce our speaker and our moderators briefly, and then we'll go ahead and let Claus share. He'll give a brief talk, and then the rest is Q&A. That's what we're here for, to do this live. Okay. Claus is a theoretical biologist with a strong interest of the application of semantics and machine learning in the biodiversity sciences. He currently leads the development team for geo and biodiversity databases in Frankfurt. He's a member of the technical team responsible for design and implementation of the overall data infrastructure and allied elements of the European Research Infrastructure for Natural Sciences Collections, DISCO, Claus is also active in Germany's NFDI program, aiming to foster fair research data on a large scale, and is a co-speaker of the initiatives for Earth Sciences, Earth System Sciences, NFDI for Earth, and the agri-systems domain. Furthermore, he's part of the Technical Advisory Committee of the Fair Digital Objects Forum, a community initiative with the objective to establish an ecosystem of fair data and corresponding services. Our moderators today, number one, are going to be Julianne Schneider. She's a metadata expert, research outputs manager, a long, weird career as a librarian working in the insurance, medical, publishing, and earth sciences disciplines. She currently works for the Pacific Northwest National Laboratory in the United States. She did go on site once and saw a tumbleweed, but mostly she works remotely. Chris Erdman, as you heard from on the call, as a community advocate, developer, and experimenter in the areas of open science and fair. Prior to joining the Michael J. Fox Foundation as the Associate Director for Open Science, he was the Assistant Director for Data Leadership at the American Geophysical Union, where he was responsible for data stewardship and drove programs in open science and fair. He's previously worked for organizations such as the Renaissance Computing Institute at University of North Carolina, the California Digital Library, the Carbon Trees, North Carolina State University, Harvard-Smithsonian Center for Astrophysics, European Southern Observatory, the Supreme Court of the United States, United Nations, University of Washington, Smithsonian, and CNET. Also, for one of our moderators, we have Andrea Medina-Smith. She is a data librarian with the NIST, National Institute for Standards and Technology Research Library Museum in the U.S., where she focuses on public access to NIST research outputs. Currently, she works with the Materials Management Laboratory's Office of Data and Informatics on the Research Data Framework, RDAF, team. She's also a PhD student at the Manchester Metropolitan University studying the role of policy in open data publication. She holds a Master of Science in Library Science, concentrating in archives management from Simmons College in Boston. Prior to NIST, she worked as a digital archivist for a small educational nonprofit. We have a link to her ORCID from the notes. Is Emma Wilson on the call today? I think she could not make it, but we're going to recognize her anyway. Emma is a PhD student at the University of Edinburgh. She has a background in neuroscience. Her current work focuses on developing workflows to automate the synthesis of evidence from animal research. Current organizer of the Edinburgh Open Research Initiative and Edinburgh Reproducibility. And also, we have several people on the call who I recognize from the list, who I hope will join in as well. Okay, handing it off to you, Claus. Thank you.
Okay, thank you very much, Donny and Chris, for the nice introduction. I think you see this all in presentation mode. Oh, that looks okay. At my side?
Yes, thank you.
Okay, thanks. Yeah, thank you very much for having me here. Yeah, as already said, I'm Claus Weiland. I'm coming with some reinforcement. It's Jonas Kriep and Alex Wolotkin from my team at Senckenberg, where we built together the group for digital collection technologies. What this is will you see in the course of the day. And I already saw some people from the Fair Digital Objects Forum in the telco, like Maggie Hellstrom, of course, who are building this ecosystem together with many people more. So there might be more than one opinion on all this, what I will present now. Please, yeah, take the opportunity to give you a complimentary review if you think what I tell you is a bit of go into, yeah, wrong direction at any point. All right. To get started, motivation, marking my background, I come from the biodiversity science, and yeah, the first slide, as I said, a little bit of opening up the topic. What we currently face is a data deluge, and this is probably not exclusive to biodiversity science. The biodiversity data providers like Senckenberg transform currently from forum curiosity hubs into curiosity cabinets into hubs of biodiversity knowledge. This is embedded in large digitalization efforts, and we will see that we work on a digital representation of what we call the physical specimen, an object, as you see here in that image on the left side, the typical specimen in a museum. There are much more types of physical material in our collections. For example, we have topic databases where we do nested sampling of these worms, accompanying soil and geolocational data, binds this all together into a certain so-called holistic sample. And additionally, besides this, what is basically dead material, we have also occurrence data, on species distributions coming from research platform like this observation of jaguar with an increasing amount of sensors who, of course, produce a bulk of data. Accordingly, we have a great variability in the derived digital material. We have the already mentioned observations. We will focus a little bit on that today. 2 and 3D images, we will cover them also. Sound recording, sequence data, associated field nodes. I guess you get the idea. This is really complex. Leading to the aforementioned data delusion, the biodiversity science, we do high throughput digitization. This is a challenge for infrastructure. For research data management, yeah, of course, with regard to transport, protocol layers, storage for archiving, the quality control of the data, both metadata and intrinsic research data, as well as the subsequent curation of the data and mobilization. I guess this is, yeah, holds for a lot of disciplines, of course. Our approach to tackle with it within the framework I'm organized in, the European Research Initiative for Natural Science Collections, DISCO, that's the acronym for Distributed System of Scientific Collections, is a so-called fair digital object approach, shown on the right side. I'll come to this in a second. Our aim is to make biodiversity data an integral part of what we describe as a globally integrated data space, which then can autonomously navigated and probably self-containedly processed by machines. That is the very first definition of what I would call machine actionability. Here are some authors from the FDOF who work on that stuff. The already mentioned fair digital objects are shown here in this little onion layered structure. In a nutshell, an FDO provides a certain number of layers, and you can go away with 3. Sometimes you will find a few more in certain figures, but I think we can get for the theoretical concept, we can go away with these 3. We have at the inner layer the resource layer, which is the actual content of your subject, and this is already an encapsulation of data, metadata, and operations on that data. You have an outer data model which specify what this in the inner layer is. We call this data model layer or FDO type. It's a and it provides a type semantic what to do with that thing in the inner part without knowing too much about that. So this is already a level of abstraction. And since you want to achieve that, you can treat the whole concept as a thing in cyberspace. So really a substantiation of something. We have a PID or PID, persistent identifier, as already mentioned in the introductory talks by Chris and Donnie, which binds that whole thing together. In our case, this will be a handle or a handle with a certain business model attached, you know, DOI or probably the IGSN are suitable here. And what a certain community does, I already mentioned that this resource layer is community provided. This is a little bit standardized by the community organization. The Fair Digital Objects Framework is to translate this conceptual model or substantiate it in your particular domain. In our case, we do this for biodiversity, FDO types, and one of them is a so-called digital specimen for these collection objects. So what we find again here is the inner metadata. We have an FDO type, and you can look in a registry. I'll come to this later. What you can do with these types in terms of operations. Some of the operations are shown here. And at least for me, but that's not necessarily so, the whole concept is closely linked and bears structural resemblance to the concept of machine learning. So here we also have the idea to enable machines to autonomously detect patterns, in this case in data, and just actions accordingly based on general purpose learning algorithms. And we have some, among the operations here, also some machine learning operations like these here, extract regions of interest. So the data encapsulated in the fair digital objects, we have a variety of data here, as I mentioned, all referring to that particular thing represented by the PID. For example, if a scan, a harbor scan is attached, we can then apply this machine learning algorithm and detect regions of interest, which in this case correspond to plant organs like leaf, flower, fruit, seed, and so on. We'll come to this later. The digital specimen is a comparatively complex substantiation of a fair or comparatively complex fair digital object type, because a lot of data types, as I mentioned before, can be associated with a specimen in a collection. For example, DNA samples drawn from something, license, under which condition can you access the whole thing, and geolocations, as well as many more. Literature, you can add data management plans to this, and the data management plans themselves can be, of course, machine actionable again. Maybe we can come to this in the discussion. What is now possible, since this basic conceptual model is more or less unified for all these kind of types, and they can look very different, is if we have a completely different type, like this one, providing semantic mappings coming from a project which is called SEPA, Flexible Semantic Mapping Framework, and who provides just these terminological correspondences between two kinds of semantic artifacts, in this case, ontologies. I also come to this a little bit later again. You can make this, you can utilize this particular digital object from this one because it already knows that it has this data model layer, which defines the type semantics for the operations, for example, to update trade information by this one, given you have annotations in this ontology, but you want to transfer them, for example, in this one, where, for example, leaf morphology corresponds to leaf morphology trait, which is just a little bit difference of wording, but probably a related or exact match in concepts. Going a bit more into detail in this, we start with a conceptual clarification. I saw this already also in the hack chat in preparations for the session, that there were several, of course, of these terminological concepts are around machine readability, interpretability, and the actionability, where we want to focus on today. This is from the FDO specs on machine actionability. I have links here for you, and I'm going to make, of course, the slides available that you have the references where the FDOF community worked on the definition. And this is not my work here. This is going straight taken from the specs. We speak of machine readability when we have somehow structured data which can be parsed by a software agent or in short machines. So this is the first level. You can probably say parsability already also to it. The next level would then be if you are able to extract or transform it into interpretative elements using a certain vocabulary which matches with this. And this is also anchored in some kind of metadata or ontological framework. We call this machine interpretability. If you have the extracted elements associated with machine readable definitions, which enable the machine to capture the meaning of the particular thing. Of course, this works in a certain context. So you need a namespace, or for example, in form of a so-called named graph, where this data lives in, which eliminates ambiguities in that. So this is closely linked to the concept of namespaces and so on, and also to description logics. What we are speaking today about is the machine actionability, and that we have the word action, so do something with the data. Because on this level here, it wouldn't do much. You can infer on it, you can apply logics to it. We will see in course of the talk very briefly how this could be done. But what you want is the full spectrum of operations, which are not all following symbolic logic, for example. But for example, these feature extraction I showed briefly before, we'll go into a bit more detail later, as this is already a sub-symbolic operations, get something out of an image. And for this actionability, we need the interpretative elements linked to a kind of repo or registry of operations, which then do something with that content. And that's our definition in machine actionability. And let me add, I haven't detailed it here, but for us in the FAIR digital object framework, and probably this is consensus with many others, this is the, so to say, philosophical core or the major emphasis of the FAIR principles. So they more or less converge to the ability of machines to do this here. Self-containedly parse the data space. I'll stressing this a bit more using a quote from Alex Hardesty, also mentioned in the MA specs, which again describes, machine readable form is linking data elements to terms. And the form then in kind of schema or whatever makes it capable, but to process it needs more, of course. We need the machine to tell what to do or how to behave in respect of a data element. And this is machine actionability. Again, what are these semantic artifacts you speak about? It's always a little bit difficult in these talks to find the right level. Probably this is very familiar to some of you. Probably others haven't heard of it too much. So I quickly explain a little bit about these semantics and meaningful elements with this figure here. Everything you see blue are
Claus,
instances.
if I may interrupt briefly,
Yeah.
maybe we could have about 5 more minutes if at all possible. Thank you so much. Great presentation so far.
All right, good. Yeah, no, all what you see here in blue is are instances of the real world. You have a seawater sampled by water sampling process and ending in a water sample associated, like the FAIR digital object before, with a persistent identifier. And what you have here now is the upper framework object provided by this structural hierarchy linked together in this subject predicate object grammar. You call these an ontology. And this ontology can all from the same ontology framework, OBO, and is interoperable by Z. So these logical constructs here are transferable. And what you see here is a ontology from another from the same domain, but from another framework, so to say, from the suite ontology. And you can do a mapping between these two concepts, which are already by verbs visible as being closely related. And then this knowledge graph is opened up for these terms. So this is the idea of semantic artifacts and interoperability within them. FDOs, as I said, promote machine actionability by encompassing, so to say, typed information and signaling potential processing steps. We call the signals the FDO type. So this FAIR digital object here is of type digital specimen, and it signals that it is available for this operation, which enables machine actionability by applying this machine learning algorithm to it and extract this feature. And of course, then it can be retransferred into the semantic world. This is a Sparkle query on the knowledge here obtained. And then you're again in this symbolic game, so to say. You can then use this to improve, for example, in this case, a global vegetation model. I don't go into much details now with regard to time. What we need to enable fairness by machine actionability is a fair ecosystem of services. Of course, the digital objects by themselves can do nothing. They just would sit in a repo with the terminology, as already mentioned. So we need an upper framework involving PIDs, involving records, involving registry, and so on, to extract and resolve and get constraints for these operations. These operations have to be registered, they have to be made available, and then they can operate on the FDO. This has to be very brief now. Maybe we can come to this in the discussion again. Just a quick example, what we do to show it in the wild. Again, this example where we use a particular museum object, a Herbar scan, let it process by this neural network, in this case, a convolutional neural network, which scans this image and then detects these regions of interest, as already said. And here we see the very same thing contained in a digital object. living in a repository. We use the software called references, and whenever such an object comes fresh with this particular metadata containing an ID again, a link to the remote image, and so on, comes to this repository, the repository detects with a service that this is of a certain type. In this case, it contains a 2D image. It sends it to a microservice, and that sends the extraction pipeline runs, and then annotations were added in a controlled vocabulary here, following again the subject predicate object grammar based on RDF. So we have our object ID here, and we can say has DC measurement value for it. These are the detected features, and there are some additional metadata associated. For example, where you find the binding box, the confidence interval, the accuracy of the machine learning detection, which is quite high here for these things because it is well trained. Yeah, and that's the whole game. Last slide and resume, because one of the questions in the chat was about the difference between interoperability and machine actionability. If they are the same, as these are of course closely related concepts, but they're a bit difficult. This is from Blumenauer and Pellegrini. I should add the quote here. I missed the quote when copying this. You have here the so-called semantic gradient, which corresponds a little bit to the inner interoperability of these semantic artifacts. So on the highest level, you have the ontologies going down to taxonomies, which are just sets of keyword words. But in the upper ones, you have in the ontologies, and when you remember the example from Envo and so on, you have the logical relations already as part of the semantic artifact. And of course, this guarantees a high interoperability within the framework. And if you have the mappings, like in the knowledge graphs, between ontologies of probably different descendants, you still have a comparatively high interoperability. This looks a little bit different when you go to machine actionability, because when you have consider these ontology frameworks and you consider reasoning on them, you have, of course, internally, given by the logics drawn from the semantic artifact, you have already high interoperability, but your options are, of course, limited, because your strength that you have internal relations is a little bit broken by you don't have the option to apply these external, probably sub-symbolic operations. The knowledge graphs do a little bit better because, as we have seen in the example of semantic mapping, you can also have a probability transformation and so on, though they're quite open to some external machine actions, but the fair digital objects are, explicitly dedicated to this. So they bring all, with the infrastructure showed, bring in all these capabilities for bringing new operations like machine learning, feature detection, and so on in. Yeah, that's basically it. And now I'm, of course, happy to discuss this. Thanks. All right.
Thank you very much, Klaus. I'm going to go ahead and hand it over to our moderators, Julianne and Andrea. In the meantime, Klaus, if you could be so kind, either now or soon, to post a link to your slides to facilitate discussion now and then afterwards.
Yeah, are you storing these? Do you want to do this in a repo? I can send it to you. Otherwise, I upload it somewhere and make it available.
Yes.
Either the link or
Yeah,
I mean,
link,
I make
please.
it shareable for now for the discussion if somebody wants to look, and then we can look over for the final.
Right. Thank you. Okay. Go ahead. Thank you. Q&A time.
Well, thank you, and I apologize for my voice. We're getting wildfire smoke from Canada in Chicago, so it's wrecked my throat. The one thing that seems to be on everyone's mind is the terms machine readable and machine actionable are often used interchangeably. Is there a need for a unified definition of the term machine actionable?
And that's for Klaus.
That's for me. Okay, cool.
Yeah, let's go over that diagram again.
Yeah, I think yes. I mean, I've shown it on the slide. I don't think they're interchangeable. Yeah, I think machine readability is of course a prerequisite for machine actionability, but machine actionability, as I tried to outline, has the action in it, and I want to do something with these things. Otherwise, they will just sit there. And in the next level, in interpretability, then yeah, you do more or less, and they can be very strong, of course. I mean, you have a lot of options. I don't playing this down, but you're a bit limited to the capability of, yeah, the symbolic logic. I'm not an expert in maybe, so it's a bit idiosyncratic, but I would say drawing conclusions, inferencing, and so on. Yeah, and probably, of course, validating and transforming also in a limited amount. But machine actionability opens this whole cosmos of sub-symbolic stuff. And I think the term machine actionability, the first time I thought this term was not in the context of fair digital objects, but I don't make this so long, but in machine actionable data management plans. And there, of course, you have the idea to transform the data management plan, which is sometimes, at least for me, a bit boring, plight, so to say, to satisfy the funders, transform it in something really useful by a lot of attached services, which plug in licensed tools. We have a UDAT license tool in Europe, or tools which reformat and extract data, for example, to transfer parts of the provenance part into something which can apply to a digital object, for example, with similar constraints. And these, yeah, active components, so today, that is for me the essence of machine actionability. That's why I'm interested in, and this is not included for me in machine readability, but that's my point. I mean, I'm happy to hear your opinion.
I just have a practical question real quick, Klaus, is that because of the question, I wonder if that's something that Fair Digital Objects FDO could set up, like a page that, you know, has all these sort of descriptions, because one of the maybe challenges too, maybe the confusions around this is that there's information in all these places across the web. And if we had like a central place where we could point things to, and FDO sounds like a really good place, is, you know, that could be like a page that we point to at FDO. I don't know if that's been considered, but it's just a practical question.
I mean, this is the would require all my diplomacy, and Maggie's in the call. I guess she's more competent to answer on that than like me. No, I mean, these ideas, of course, of this actionable knowledge unit and binding things together is not exclusive to the FDOF or to the FDO. This is a very old idea, so to say, dating back, yeah, from the development of the internet in form of datagram or TCP/IP-based data exchange. I mean, Rob Kahn was, of course, fundamental also to this concept in a, I think, 2005 paper, which dates back from a draft of the 90s also. So very early, they were aware of that this object dimension or substantiation of something into a thing in cyberspace that came very early. And I think now we have, the research data institution and so on have the possibility to make this true. And this is a process, of course, of specification. And there are probably certain candidates for this specification. And we are currently in a process of, yeah, sometimes fruitful alignment, and sometimes, yeah, we need a bit more time to explain. So I wouldn't claim for FDOF, from my limited perspective, as being active in a few of these groups and writing a few of the standards. I don't say we should go for now world dominance and explain everybody how to do this. This has to be a cooperative project. I think some people already mentioned similar approaches like signposting based on traditional RFC 8222 based web linking and so on, as well as the RO create, research objects crate is also a similar approach. And we're now trying to develop boundaries and synergies together with these approaches. And I think this is the current process from my perspective. I'm not sure, does this answer your question?
Oh, yeah, I mean, collaborative approach, yeah.
Yeah, I don't think I wouldn't put in. What we put currently on the web is the FDO specification as we see it in the FDOF. I mean, as I said before, machine actionability in context of data management plans, for example, they have a longer transition than the usage of the term by FDOF, I think.
I guess a follow-up question might be to that is machine actionable can be in conflict with human readable. So how can both be best taken care of? And that, I guess, goes to any one of you, because you all sort of cover that.
I can take a stab at this briefly. I started to write it a little bit in the chat in the document. So one of the things with the web with HTTP is this keyword. It's called content negotiation, and the idea of this is it works transparently to you. Often when you have a web browser, it will your machine, your browser will send a request to a resource over the web, and it will say what kinds of media it wants, and it will usually prefer an HTML representation, and that will be a web page. Often with these digital objects is you can send something else. You can say, actually, I would prefer this other type, and there's sort of a registry of types. So that may be something more amenable to a machine. You might say, like, I would like this in JSON, please, and you can do that with an accept header. And so that's one of the examples that I feel is pretty good, where, you know, given someone's interface, they can with the same resource identified using its metadata, there can be different operations like return me something human readable, return me something in this format, and there are ways to specify that. So that's the way that I think would be good to look towards. I don't know if Claus or Chris have more specific thoughts on that or elaborations.
No, I actually, yeah, completely agree. I mean, the difficulty, if I get you right, and I think what I think is a little bit of the difficulty is you want, of course, to keep that. You want to keep the description or your object still declarative for humans. So making everything machine actionable shouldn't mean that it's not serializable, I would call it, into something declarative by humans. And that's also, I think, a little bit the idea of the reporting concept in machine actionable data management plans, that you probably have different kinds of comprehensiveness, how you put something, how you structure your output. And what we concretely do, Jonas, who is here, Jonas Grip from my team, is he's working a lot with a comparatively simple, compared to logical reasoning, a comparatively simple schema language for the RDF data model, which plays a major role for us, at least, in this concept called shape nodes, shacks, and shakel. And they're quite good in transforming content into something readable by humans. You can still use it. It's yeah, like JSON schema, if you know that, and so on. So that helps you to grasp the idea what is behind before you blindly hand it over to the machine, for example. That's the idea. But of course, yeah, it's a task to keep the human, of course, in the loop, or to enable him, her, to remain in the loop.
And Dara, do you have a question that you want to ask?
Sure. So, sorry, I lost our list of questions for a minute there. Let's go back to best practices. So, are there any best practices that have been established for making a file machine actionable? Can we adopt any practices from one discipline to another. I know that you're focused on the biosphere. So Claus, that would be for you. And also, I guess, Donnie, that would be a great question for you.
Yeah, Donnie, do you like to start? I don't have to talk all the time here. So, and maybe Jonas or Alex, if you want to jump in, of course, I'm happy if you can share your best practices. I mean, what we essentially do is there's always a little bit of internal discussion. How do fair digital objects relate to the linked data approach, which are probably all of you familiar with. So this world of semantics, I strived at least in my talk. Because in the beginning, these FDOs, or the oldest approach came straight, it is related. You have DOI, Digital Object Identifier. They are linked to their own approach called Digital Object Architecture, and they come with their own protocol called DOIP, Digital Object Interface Protocol. And they're a bit separated world of the semantic web community. And what I think is it makes perfect sense to unite them. So I mentioned the Cordra middleware we use to develop these repositories. This is one of the more common softwares or server applications to be used with to enable you to build up fair digital object repositories and all of the registries. And Cordra by default works with JSON, and we exploit a little bit that every JSON LD, so the linked data implementation of JSON, is also, of course, if it's valid JSON LD, it's also valid JSON. And we try to make in digest JSON LD, but we keep, so to say, the links to the semantic web world. So I wouldn't trade, of course, the option to serialize into something which corresponds to the RDF data model like JSON LD. So that's a bit of my recommendations or our best practice. And I think what Donnie already mentioned with schema.org, which is of course also valid, a valid RDF serialized to JSON LD. That's quite interesting to work in this field. And I think, or I expect to see a bit more from the before pure digital object architecture FDOs go into this FDO plus LD way. That's what I think, because you keep the interoperability with semantic web world, which is of course huge, in particular in life sciences, biomedical health, and so on. And I want to keep that compatibility.
Thank you, Claus. Chris, you got your hand up.
Yeah, well, I just wanted to maybe have some thoughts about this too, Andrea, but I just a brief like sort of response to that is, if we're talking about the researchers as far as best practice versus like the infrastructure developers, you know, best practices for them, I was thinking, at least for researchers, is that we're trying to weed through all the noise to some. It's not noise, it's just a lot of helpful information from all of us. And I think, like, at least from the funder side, from where I sit at Aligning Science Across Parkinson's and Michael J. Fox Foundation, is that we're just trying to get to the like to the instructions, the really step-by-step that a researcher needs to do, right? Like because I think that's one of sort of the challenges that actually as a community we're all like trying to get to at the moment too, is so at least from our perspective, we're trying to take that approach, which is do these things and the minimal things that we're looking for, and then iterate on them. And
that was really what my next question would be like, what is it that you want researchers to do to help build out that final picture, final diagram that you showed, Claus? I think Donnie, you probably have some insight into this too. What is it that researchers on the ground can be doing, and librarians and other support staff pushing toward that we haven't maybe heard, or maybe you guys have spoken but haven't really spelled out for us, because it's early for some of us here, and we need it spelled out.
Shall I answer this, or yeah?
Please.
Yeah, go ahead. Yeah.
The research is on the ground. I mean that graph was not so much to yeah, I mean, these things shown there follow different purposes. I mean, folksomies, I mean, they have, in particular for findability, yeah, they have, of course, their purpose. And sometimes you want, for example, a thesaurus, which don't comes with these complicated symbolic representations, but basically says, this is my parent and this is my parent. So all the relations between them are subclass of and the like, and probably close related concept or broad topic, I think is a term in the thesaurus, or SCOS, exact match, something like that, but limited compared to the full spectrum of relations which is possible with OWL or other high-level ontology modeling languages. From my limited understanding, I mean, they follow different purposes, and you sometimes don't want this overhead. I just compared the semantic artifacts. I didn't say this is a low level of if a researcher also can do only that, because he might have good reasons for that. And I think the next step is clearly, insofar as people want to do this fair digital object and want to test it, they need something like a test bed. And this is absolutely on the task list of the fair digital object forum to provide this easy FDO testing environment. And this is something which has to come up in the next month, of course, giving people the opportunity to really play around with these technologies, because other side, you won't get much more far than having your object sitting in a repo and doing nothing. But you want to, of course, play with the full capability of self-contained parsing of data spaces. So this testbed infrastructure is something which has to come, and which the linked data world, where these techniques are a little bit easier to implement, since the operations you permit are all internally bound and more foreseeable to the discovery and inference aspect. There you have these linked data playground and so on. That is not, it's, yeah, I don't say you just go cheap to build something like this, but it's a little bit more overhead in the case of fair digital objects, where you need these overhead of registries to achieve interoperability and machine actionability. But this is something we have to set up as Fair Digital Objects Forum to give the opportunity to play with, and then it is more easy for people to work on it, because when you compare it again with the semantic world, I mean, people started to with these so-called Sparkle endpoints, where you can do these queries, which I quickly showed, select like SQL typed queries of data sources. And in the first steps, this was probably experimental. But then people started and discovered that they can do fantastic things with that. For example, use a Sparkle so-called service call. You use the service keyboard and you can connect sequence data from GenBank, EBI, or another INSDC, the other INSDC database, and connect it with protein data, for example, from UniProt, and make fantastic queries connecting these things in what later becomes then something like the linked data cloud. And FDOs, of course, need something comparable, show the full range of types, because many FDOs now, I would say, are helpers or are simple. They covering, for example, like the one for the mappings, also something which is not useful per se, but makes sense, of course, if it's linked to a digital object which is annotated with a certain kind of semantic artifacts, and want to open up content annotated with the other one. Yeah, I think testbed is our task next. Yeah.
Thanks, Klaus. Donnie, do you have something to add to that?
Sure, I'll just add briefly something I was just thinking about. I put it in the chat of just like a really small next step. And I think the crux of it, from my perspective, is to make the terms that people are using in their data sets, when they say things like depth, pH, measurement, all these things, try and make those terms addressable. For example, as links. One little thing you can do is having an HTML page, and there are ways you can link tags so that when you have a link to it, you can go right to that part of the page, like we did with the bookmarks in our Google document, actually. And if you then link to those things in your data sets, then people can actually address those things. And then some of the semantic infrastructure people can do things like mappings and like take what you point to and say that it's a SCOS exact match to this other vocabulary and do all these interoperability things. But I think the crux of it, the small step, is to actually try and give these things URIs in any way that you can, and make them addressable, so that people can know if there are false agreements or false disagreements between terms. So I think that's sort of one thing, just to get people in the mindset of uniquely identifying things. And then, in terms of whether you do RDF or whatever, that can come later. But that's sort of the mindset of being able to identify things, because then you can attach types and operations and all these sorts of things. But you don't really have that until you know exactly what you're talking about. So that's what I'd like to maybe draw people's attention to. Yeah.
Great. That's something that researchers can be looking at. And Chris, you have a answer, and you said that I might not like it, or everyone might not like it. And I have a feeling what you're going to say, but continue.
Well, yeah, having to work with all this and being sort of in a fairly advanced state when it comes to open access, or sort of open science policy from other funders, we're still at very basic levels here. And so I would say the one thing that, because we're talking about all the things that all these great things, right? Like, and I totally agree with it. But at the basic level, the where they're publishing has to be open, right? Like, because at the moment, researchers are doing all sorts of different things with sharing their data and software and doing all those things. And so that, at least as a bare minimum, from our standpoint, is that we need to have a DOI and we need to have an open paper, because we have to, unfortunately, mine this information at the moment, and even we are a little bit more advanced than other funders and other places that are doing that, so like that's a bare minimum. And unfortunately, again, the next step that this is our bare minimum, that what we're trying to tackle with our community and culture at the moment, is at a bare minimum, we still don't have anyone using like fully the availability sections and starting to link out in very, describe what they're doing with data and software in some minimal ways. And so, that's where we're at from a very practical step. We're just saying, you know what, we're going to have to like be very general at this point with our researchers, and then build from that, right? Like, and we do have discussions about how to structure your data, how to do all that stuff. We do that work, but that's a lot of work. That's what we're working on right now with all of them.
Thank you. All right. And we'll move away a little bit from that balance between what researchers can be doing today and what we see in our blue sky future. Somebody posted a question about the relationship between, or what is the relationship between machine actionability and automation? So there are a collection of tools or case studies demonstrating the automation of workflow steps, hopefully some with low effort. Those are, I know I've seen some case studies. I don't know that I know of a collection of them, but yeah, there are some things out there. I know that. Anybody who's working in this a little bit more heavily than myself, than I am, can you make any recommendations? Well, I would recommend, I can see if I can find some of those, and I will post them to our group chat or the collaborative notes later this morning after I do some searches. Is there any particular, the person who wrote that, is there any particular discipline that you're looking for? You can just put that in the chat or in under the question. Okay.
Actually, oh, sorry, I should put my hand up. Sorry. I just like to say I've worked with triple stores for a while, and honestly, the biggest challenge with Sparkle is understanding the graphs that you're working with. Because if you can't visualize the relationships, you can't really be sure that you've captured everything that you think you are. So that's my biggest challenge.
Did you say a visualization tool? Did you mention a tool, by the way, Julian? Just wondering. I missed that.
Oh, no, I did not. I will say that there is, it used to be free, but it's now not. OntoForce has a really good sort of interface where you can work with triple stores, but they kind of hide the sparkle behind a really nice interface. So that's really nice. Of course, then you don't learn the sparkle. But there are people working on making it more human, interactable with, I'm sorry, my brain's melting.
Okay. All right. Well, are there any other questions that we?
And Andrea, I'd like to just briefly, I'm typing this in the chat now, but I do want to say that in terms of machine actionability and automation, you know, I'm familiar with things not so much involved in a lot of the tools we've been seeing, RDF, but so for example, there are tools like I work with this Python-based workflow orchestration tool where you use Python utility classes in order to make actionable other Python code in the context of this framework that will run it. And for example, I'm helping run workflows and manage metadata for the National Microbiome Data Collaborative in the U.S. With that, but it's sort of Python based, so where the actions are Python code, so it's less semantic. And the other thing that I'm familiar with in that context is this WDL workflow definition language, where people will like run workflows based on that. And so it is a code based approach, but it's not quite semantic annotation. But these are sorts of things that get at the power of decorating things with controlled vocabulary in order to get them to run and then not have to do so much imperative work. So that's something I might point people to.
Thanks, Donnie. And this is a really basic question. I maybe should have asked it right at the top after Klaus's presentation. To make things machine actionable, do we have to be using semantic web techniques, or are there other ways to do it? And semantic has just floated to the top. Curiosity, I could be totally wrong. It could be the way. And I'm just not knowledgeable of it. Chris.
Yeah, I have another example. Maybe this is not a good example, but I'll just mention it. So in sort of publishing notebooks, right? So in my previous life, I was involved with the Sloan grant for making notebooks more, just more of a first-class object in the research system. And so, that involves like notebooks use, either like Jupyter notebooks, or you can look at sort of the R ecosystem and what they're doing with Quarto. But on the the Jupyter side, there's MIST tools, and it just takes really like things like JSON or Markdown. And, they're also looking at what does that look like in JATS, which is the journal, XML format. And so it's more about sort of like converting, between all these different formats. So like that's more XML based, and but I don't know if that was a good example, but I'll include the link to MIST tools if anyone's interested in that.
Great, thank you. Donnie?
Yeah, this is maybe a bit of a strong opinion. I don't know if other people will stay on the call, but my impression is that for a lot of the non-RDF based approaches, what they'll end up doing is ultimately reinventing a lot of RDF, and often poorly.
I'm sorry, are you saying RDM?
Oh, sorry. The research, the resource description framework.
Thank you, RDF. Okay, sorry, the last part got a little.
Right, which is the basis of the semantic web stuff. So for example, I mentioned, there are ways of doing it in bespoke languages like Python or various things. But so there are various approaches, but I think one of the things a lot of people are trying to do with Corridor and these sorts of things is trying to get over the idea, well, we want to identify things, so let's give them URIs. We want to relate things, so maybe we can relate them with triples. So I believe that's what you're getting at. They are related, but I think there's a drive to make a lot more usable this this highfalutin, for a lot of people, thing, Sparkle RDF, because we end up sort of repatching parts of it that we need to, and making that accessible for researchers. So that's sort of my take on that. Yeah.
Thank you, Donnie. Anyone else have questions that they'd like to ask?
Just let me add quickly. I mean, there are, of course, a lot of techniques imaginable which link type definitions to operations. Yeah, it hasn't to be the semantic technologies, but it makes it easier, and it also bridges, of course, then into the semantic web world. So for us, it makes sense to relate to that framework. But of course, as I said, the traditional, in quotes, fair digital object approach would use and employ other techniques to access the operations in a registry. It's just key value attribute.
Right. All right. Thank you, Claus. Well, I think I will hand it back to Donnie and Chris to wrap us up.
Well, thank you. I think I point to Donnie, or maybe it's both of us. But it's just a sort of a quick thank you, and then thank you everyone for participating, and we will share out this material and just recommend sort of signing up. Yeah, and thanks, Donnie, for adding the link, and recommend sort of signing up to the resources that we had in the notes and the slides. So joining the Slack or the subscribing, so you can find out about other events. But otherwise, I wanted to thank everyone. We had a children's show back in the day. I want to thank Klaus. I want to thank Donnie. I want to thank Andrea, or Andera, is as I'm seeing in your name right now. This is your alter ego, and Jillian, of course. Yeah, I mean, really, we pulled this off with all the sort of illnesses, and I think we had sort of emergencies and illnesses, and Julian's poor sore throat. So I just wanted to thank everyone. And Donnie, if there's anything I missed, let me know, or speak up right now. But thanks, everyone.
No, that was great, Chris. I just tried to throw some links in the chat as an effort for people to click on them. We have a Slack community event series, and please add any thoughts in the document as you see them. We'll sort of wrap it up later, but feel free to add some last thoughts, in the document even after the call. Thank you so much for taking time out of your busy schedules to join us and talk about this and try to improve our collective understanding of this stuff. Thank you, everyone who's been involved. Especially our volunteer moderators. Thank you. Okay. Have a great day, evening, wherever you are, everyone. Yeah.
Good. Then let me say thanks again also.
Yes.
I'm very curious about the upcoming program. So I'm really curious for the Hugging Face stuff, I confess. Okay, thanks.
Take care of your throat, Julian. Take care, everyone.